sometimes when we solve equations or are working with equations, we find that they might not have any solution at all, which means no matter what value you would plug in for x, it's never going to work out. It's just not possible to solve. Or the opposite could be true, where any value for x works, which means every single answer is a solution. We call that infinitely many or all solutions. And when we have no solutions, some examples of what that might look like when you solve that problem is you might get something that's not true. Maybe you'll have 3 equals 5, something that is not true. So you've solved everything down and this is what you're left with. This would tell me that there's no answer because 3 is not equal to 5. So that's going to tell me that there's no answer to this equation. Or another example would be negative 2 is equal to positive 7 is not true. Or 0 equals 1. Anything that's not true would be no solutions. On the other hand, if it's always true, for example, 3 will always equal 3, or 0 will always equal 0, that tells me that it doesn't matter what value I replace x with, or whatever my variable is, it's always going to work out. So they're all solutions, or infinite solutions. And then, of course, we have all the different equations we've already looked at where we have one solution. That's when you solve and you get x equals 3. There's one solution, it's 3. Or m equals 5. There's one solution, and it's 5. So we can't forget about all those other equations that we've already learned how to solve. So with no and infinite solutions, we notice that there's no x left. The x's all cancel out. And then the better we get at these, we'll start being able to recognize which one it is without even having to solve the whole problem. But for now, we'll look at the whole problem. So on number 1, I notice I've got distributive properties, so I'm going to go ahead and do that first. So 3 times x is 3x, and 3 times positive 4 is a positive 12. And that's not going to affect the right-hand side. And then I can see already that this is going to be no solution, and that's because I can tell that these things are not going to be true. I have a 3x on both sides, and those match. So if I take this identical thing, and this time I add 12 to it, but this time I add only 11 to it, I'm no longer doing the same thing to both sides. But let's solve it to verify that that is indeed true. So I could do minus 3x from both sides, minus 3x. This cancels out because that's 0, but 3x minus 3x is also 0, so that cancels out as well. So when the variables cancel out on both sides, what am I left with? I'm left with a 12 here and equals 11 here, which is not true. 12 will never equal 11, so this means that there is no solution to this equation. It's not possible. Same thing here. I notice I have a 2x and a 2x, so I have a group of 2 of something and a group of 2 of something. And here I'm going to take away 7 from that group, but here I'm going to add 5 to the group. So I'm already not equal, but let's solve it to verify. So I'm going to subtract the 2x from both sides. Not only does it cancel out here, but it also cancels out here, which means I'm left with a negative 7 equal to a 5, which again is not true. So this means there's no solution. On number 3, I notice that these are identical. 4x minus 2, 4x minus 2. They are the exact same thing. 4x minus 2 will always equal itself, but let's solve it to check. So if I minus the 4x from both sides, just like we do when we're solving an equation with variables on both sides, this cancels out, but so does this, and I'm left with a negative 2 on the left, but I'm also left with a negative 2 on the right. And negative 2 will always be equal to negative 2. This means there are all solutions or infinitely many solutions. So however you want to say that, as long as you recognize all those as a proper answer. I'm going to say there's infinite solutions. So infinite, infinitely many, all solutions. On number 4, I can't really see right away. There's a lot of things going on that right-hand side. So let's simplify this one first. So there's nothing I can simplify on the left, so I'm just going to keep that the same. But on the right, I can do distributive property. So that's 2 times 3x is 6x, and 2 times negative 8 is negative 16. That finishes that distributive property. I'm just going to drop down that minus 2. And then I'm going to keep all this the same. There's nothing I can do here, but I can combine these two like terms over here. Negative 16 and negative 2 make negative 18. Well, now I'm noticing they're identical on both sides. But just to be safe, I can go ahead and solve this. I can minus the 6 from both sides. And that cancels here and here. And I'm left with the negative 18 equal to a negative 18, which is always true. So there is an infinite number of solutions, which means every single answer is going to be a solution. Write an equation that has no solution. Well, so if I start with, for example, 8x on this side and an 8x on this side. So far, these two things are exactly the same. But to make no solutions, I need to do something different to them. So if I add, right now my two sides are balanced. They both have 8x on it. If I add 1 to this side, but then I add 5 to this side, I'm no longer balanced. I've added too many. So this would be an example of no solution. I can tell because I started with the same value, 8x and 8x, but then I changed them a different way. I added 1 to the left, but I added 5 to the right, which makes it out of balance, so no solution. To be an equation that has a solution, it has to be in balance to begin with. And the last one, write an equation that has infinitely many solutions. So this could be, for example, if I start with a 4x and I add 9 to it. So then if I have a 4x on this side also, if I add a 9 over here, I have to also add 9 over here to keep that balanced. So if we start with the same value for the variable and all of these, but what's different is if you want it to be all solutions, you do the same thing to both sides, like plus 9 plus 9. If you want to be no solutions, you want to do different things, like plus 1 and plus 5, or I could add 1 and minus 1. So again, though, we want to remember that we do have a third option. There could be one solution. We looked at all of these examples. We noticed that the x's always cancel. The x's always cancel. So if we have an equation like this, for example, and I would need to get the variables on the same side. So minus 6x, minus 6x. This cancels, but it does not cancel over here. This would be negative 4x. So as soon as I see that the x's don't all cancel, that tells me I'm going to have a solution. And if I keep solving this, I see that that solution is going to be negative 3. So that's the difference, was right here, is that the x's did not cancel on both sides. They only canceled on one side. On all these others, canceled on the left, canceled on the right. X canceled on the left, it canceled on the right. Canceled on the left and the right, canceled on the left and the right. If they only cancel on one side, that tells me I'm going to have a solution because I have an x left. And if I have an x left over, I can solve it. So if this asks me how many solutions, it has one solution. And then that one solution happens to be, in this case, negative 3. So sometimes we'll have one solution, sometimes we'll have no solutions, and sometimes we'll have infinite number of solutions.